Hello everyone. This is a GCSE revision video of a series where I discuss past papers and model questions every week to prep for exams. Many of these questions are relevant for high school maths qualifications around the world, like O-Levels, AP and SSC. For detailed explanation, I have made topic-based theory and question videos. You can check them out on my channel. Question number 1. In this question, you have to write this fraction in this form, a plus square root 5 over b, where a, b are integers. In this fraction, you can see that third in the denominator. Therefore, if you want to get this form, you have to remove this third from the denominator. That means you have to rationalize the denominator of this fraction. Let's see how we can do this. First, you can simplify square root 180 as square root 36 times 5. You can take square root separately. This equal to 6 square root 5. Therefore, you can write this fraction as 6 square root 5 minus 2 square root 5 over 5 square root 5 minus 5. You can simplify the numerator, that's 4 square root 5 over 5 square root 5 minus 5. Now you can rationalize the denominator. You have to times the denominator by 5 square root 5 plus 5. Do the same thing to the numerator. Now in the denominator, you have factors of difference of squares. Take 5 square root 5 as a and 5 as b. So you have a minus b times a plus b. That equal to a square minus b square. Therefore, you can write the denominator as 5 square root 5 square minus 5 square. You can simplify the numerator, times this by this and this by. To continue with the series, check the next video. See you in the next one. 5 square to square root 5 is 5. So we're going to get 125 here, minus 5 square is 25. This equal to 100 plus 20 square root 5 over 100. Now you can see you don't have third in the denominator. To get this form, what you have to do, you have to divide each of these numbers by 100. You can simplify this. This equal to 1 plus square root 5 over 5. Now you have this form here. If you want, a equal to 1 and b equal to 5. Question number 2. In this question, two functions are given, f of x and g of x. We have to find these function values. Let's see how we can do this. Part A, you have to find g of 5. So write down function g of x. To find g of 5, you have to substitute x equal 5 into the function. That would give you g of 5 equal to 3 bracket 2 times, substitute x as 5 plus 1. You can simplify this. Inside the bracket we have 2 times 5 is 10 plus 1 11 times by 3, that gives us 33. So g of 5 equal to 33. Part B, you have to find g of f of 9. Here we have composite function value. So what we have to do first, you have to find f of 9 first, then substitute that value into function g of x. First find f of 9, therefore take function f of x equal to 12 over square root x. Substitute x equal 9 into the function. That gives us f of 9 equal to 12 over square root 9. Square root 9 is 3, so you have 12 over 3, that's equal to 4. Now take function g of x. You have to substitute x equal f of 9. Now substitute x equal f of 9, that's equal to 4. So you would get g of f of 9 equal to 3 brackets 2 times, substitute x as 4 plus 1. You can simplify this. 2 times 4, 8 plus 1, 9. 9 times 3 is 27. So g of f of 9 equal to 27. Part C, you have to find inverse of g of 6. To find this value, first find inverse of g of x. To find inverse function of g of x, take g of x as y. Now make x as a subject. 6x plus 3. Then you would get y minus 3 equal to 6x. Divide both sides by 6. Thus gives us x equal to y minus 3 over 6. This is your inverse function, so you can write it as g inverse of x equal to x minus 3 over 6. Now you can substitute x equals 6. You can simplify this. 6 minus 3 is 3 over 6. That gives us half. Question number 3. In this question, C is a circle with the center, the origin. So you can draw this circle on the xy plane. They say that the center, the origin, so coordinate at the center as 0, 0. A tangent to C passes through the point minus 20, 0 and 0, 10. So let's draw the tangent line. We can write these coordinates here minus 20, 0. This coordinate here 0, 10. I'm going to label this point origin as O. This point here I take as A and this point as B. You have to work out an equation of circle C. You must show all your working. Let's see how we can do this. As the center of this circle is 0, 0, we can write the equation of this circle as x square plus y square equal to r square. Therefore, if you know the radius of this circle, we can write the equation of the circle. So the matter is, we need to find the radius of this circle. According to the circle theorems, if you draw this radius to the tangent, it's perpendicular to the tangent at this point. I'm going to label this point as P. Now, if you know coordinate at this point P, you can find PO length. How you can find coordinate at this point? What you can do, find equation of this AB line and find equation of this line OP. If you solve that two linear equation, you can get intersection point here. To find the equation of this line AB, tangent line, you need to know gradient of that line. So let's find the gradient of that line first. I'm going to label gradient of this tangent line as M1 and I'm going to label gradient of this radius line as M2. As you know two coordinates on the line, you can find M1. M1 equal to difference of y coordinate over difference of x coordinate. 10 minus 0 over 0 minus minus 20. This equal to 10 over 20 equal to half. As these two lines perpendicular, we can use the property of perpendicular lines. M1 times M2 equal to minus 1. Therefore, we can find M2. M2 equal to minus reciprocal of M1. As we know gradient M1 as 1 over 2, M2 as minus reciprocal of half is minus 2. Therefore, you can find equation of line AB. Take it as y equal mx plus c. You found M1 as half. So you can write this equation as y equal half x plus c. You need to find c. Actually, we know c here because it's going through 0, 10. Therefore, c equal to 10. We can write the equation now y equal half x plus 10. I take this equation as equation 1. You can write equation OP easily because it's going through 0, 0. So equation OP has y equal mx form. We found that the gradient of that line M2 equal to minus 2. Therefore, we can write OP line y equal minus 2x. Take that equation as equation 2. When you solve these two equations, you would get intersection point P here. To solve this, you can substitute y equal minus 2x into this equation. That would give you minus 2x equal to half x plus 10. You can times this equation by 2. That would give you minus 4x equal to x plus 20. When you solve this, now you can bring this plus x to this side. That gives us minus 5x. If you divide both sides by minus 5, you would get x equal to minus 4. Substitute x equal minus 4 into this equation. That would give you y coordinate. That's going to be plus 8. So here, this coordinate, now you can write as minus 4, 8. Now, we can find OP length as we know coordinate at point O and point P. If I remind you this, when you have AB line segment, if you know the coordinate at point A and point B, you can write AB square equal to difference of x coordinates is square plus difference of y coordinate is square. Therefore, you can write OP square, that is the radius is square, equal to 0 minus 4 is square plus 0 minus 8 is square. So r is square equal to 16 plus 8 is square 64. This is equal to 80. Now you know radius is square, therefore you can write the equation of this circle. So equation of circle is x square plus y square equal to 80. Question number 4. You have a vector question here. They allocate 4 marks for this. You have DEF triangle. They says that P is the midpoint of FD. Therefore, FP length equal to PD length. And Q is the midpoint of DE. Therefore, DQ length equal to QE length. They says FD vector equal to vector A. Therefore, we can say that FP vector is A over 2 and PD vector A over 2. And FE vector is B. You have to use vector method to prove that PQ line, this line, is a parallel line to FE line. Let's see how you can prove that. Let me remind you this. If you can write vector AB as a scalar multiple of CD vector, here lambda is a constant, then you can say that AB line segment is a parallel line to CD. Therefore, if you want to prove that PQ line parallel to FE line, you have to get a result something like this. PQ vector you should be able to write as a scalar multiple of FE vector. Then you can say that PQ line segment is a parallel line to line segment FE. Let's see how you can get a result something like this. Here lambda is a constant. We know FE vector, it's B. Therefore, what you have to do, you have to find PQ vector. To find PQ vector, you can take this triangle PDQ. Using triangle rule, you can write PQ vector is equal to PD vector. So you can write PQ vector equal to PD vector plus DQ vector. We know PD vector is half A and DQ vector we can write as half DE. So we can write PQ vector equal to half A plus half DE vector. I'm going to take this equation as equation 1. Let's see how we can find DE vector now. To find DE vector, you can use DFE triangle. And using triangle rule, you can write DE vector equal to minus A plus B. Using triangle rule, you can write DE vector as DF vector plus FE vector. FD vector is A, therefore FD vector is A, therefore we can write DF vector as minus A, and FE vector is given as B. We have DE vector equal to minus A plus B. You can substitute this result into equation 1 here. That would give you PQ vector equal to half A plus half DE, DE equal to minus A plus B. We can expand this bracket. That gives us PQ vector equal to half A minus half A plus half B. So you can cancel out this half A to this half A. That gives us PQ vector equal to half B. Vector B equal to FE vector. So you can write PQ vector equal to half FE vector. You can see, as you expected, we have a result something like this. Here lambda is half. Therefore, now you can say that PQ line is a parallel line to line FE. To continue with the series, check the next video. See you in the next one.